Hello everyone, let's talk data. Today we will talk about basics of data cleaning. For this video, we will take artist toward dataset. So first thing first, why do we need data cleaning? We get our data from various sources. Sometimes data is entered manually, sometimes from web scraping, sometimes from the points of sale system, and sometimes from various unknown sources. These data may have some abnormalities. That includes missing value, duplicate rows. There may be some data type mismatch or inconsistencies in the data, or there may be certain part or the chunk which we do not need or that is irrelevant to our use case. So in order to train our machine learning models and AI models on these data, it is advisable to clean the data and prepare it for better predictions. So let's dive in. On this dataset, we will perform following steps. First, we will inspect the data. Second, we will handle the missing values. Third, we will handle the inconsistencies in the data. Fourth, we will handle the data type mismatch. Fifth, we will know how to drop rows and columns that we do not want. And sixth, handling the duplicate values. So first, we will inspect the data. For this, we need to import some libraries like Pandas and numpy. We will import Pandas as PD and numpy as NP. These are aliases of our library. So the Panda will be used as PD and numpy as NP. So Panda is a library which is used for data cleaning in Python. Similarly, numpy is a library which is used to manipulate numerical values in our dataset. So first we will provide the URL or the path of our dataset. So our dataset is in the form of CSV file or comma separated values file. So in Windows, when we give path of our file, so it contains certain backslashes. So in order to pass this URL into our pandas data frame, we need to convert the backslashes into forward slashes. So we have already converted the backslashes into forward slashes. So now we want to convert our CSV file into pandas data frame. So pandas data frame help us to visualize our data better in the form of rows and columns. So let us convert our CSV file into pandas data frame. To do this, we need a method called readCSV. So we will simply write pd.readCSV and pass our URL to the readCSV method and it will be converted into a pandas data frame. Now to see our data frame, we have a method called .head. .head method will give us the first 5 rows of our pandas data frame. So this is our pandas data frame. So looking at this, we can know a lot of things about our data. First of all, we can know what are our rows and columns. We can know what are the values and if there are any missing values. If you want to see more number of rows than just 5 rows, we can pass a numerical parameter into this parenthesis like we have done here. So we can pass df.head in parenthesis we have passed 10 so that we can see the 10 topmost rows. So now we can see our 10 topmost rows. We can also see the last 5 rows of our dataset. For this, we will use function .tail. In this also, we can pass any parameter, any number or numerical parameter, and we can fetch the number of rows we want. So these are the last 5 rows in our dataset. So in order to know what is the shape of our dataset or what are the column names of our dataset, the dataset may be large and we may not be able to see all the columns or the data at one go. So to know the attributes of our dataset, the data frame, the pandas data frame have some attributes. So first attribute is dot shape. With dot shape, we can know what is the shape of our dataset. So like here, our dataset has 20 rows and 11 columns. The first one is the row, the second is the column. So it has 20 rows and 11 columns. We can also know the dimension of our dataset, if it is 2-dimension, 3-dimension or 1-dimensional dataset. For this, we use the attribute ndim. So our dataset is a 2-dimensional dataset. Now we can know what are the data types of all the columns in our dataset. For this, we use the attribute dot data types. So with df dot data types, we got all the data types of our columns. Here we can see that rank and shows are integers and rest all are objects. Now if we want to know what are the column names in our dataset, we can use the attribute dot columns. With dot columns, we can know what are the name of our columns. Now if we want to combine all the information above into one set and give the information about our dataset, we use the function or the method called .info. So we use df.info to get the information about our dataset. Here we can see that there are name of our columns, how many non-null values are there in our columns, what are the data types, what is the shape, 20 entries and columns, 11 columns, what are different type unique data types in our dataset, there are integers and objects, and the memory used. Now if we want to know how many null values are there in our dataset, null values are missing values. They should not be confused with 0. 0 is an integer. So null values are actually the missing values. For this we can use isNull method. If we use isNull method, it gives us the Boolean values. It will inspect all the elements, all the data elements in our dataset and tell if it is null or not. So if we run this, so it is giving us false or true. So wherever there is true, the value is null. Wherever there is false, there are some values. But how we can know the aggregated null values or the total null values in each column? So to know the total null values in each column, we will use isNull.sum. So there are two methods, isNull method, and then we will combine it with sum. It will give us the total null values in each column. So we can see in peak and all-time peak, there are some null values. So now let's see some methods of data slicing. So methods of data slicing are used to get hold of a chunk of our data or part of our data from our whole data set. Like if we want to get hold of a single column and change its values or manipulate it, then we can do so. For this, we need these square brackets. First, we write our data frame name like df, then square bracket and write our column name. And we can make an object of it like we did here. So if we see, this is the peak column. The name is peak and these are all the values in the peak column. Now, if we want to change the values in the data frame of a particular column, then we can do this by getting hold of that column df square bracket shows is our column, and then we do some mathematical operation like -1. We remove 1, we subtract 1 from the column, and then we put these values into our data frame. So if we see our data set now with df.head, now our new value is 1 less than the previous one. So now it is 55. Previously it was 56. If we want to slice a chunk of our data, we can do so by using iloc method. In iloc method, we chunk our data df with using .iloc and then square brackets. In square bracket, we pass two parameters, first row, then column, separated by comma. When we pass the row, we have used just colon. This indicates that we want all the rows. In column, we have used 0 and 10, a colon. That means we require columns from 0 to 10, but not included 10. So it will give us all the columns from 0 to 9. So now if we see df.head, it gives us df and .head. It gives us all the rows and the columns up to 9, not the 10th. The reference column is dropped. We can see the shape of this data frame. With df and dot shape. So previously our data had 11 columns, now it has only 10. Now handling missing values. So we can handle missing values or the null values by various methods. It depends on the type of data, the size of data, and the problem at hand. So first thing we can do is to drop the null values or drop the rows and column that contain null values. We do it when our data set is very huge, and dropping a few rows and columns with null values don't make a much change to our outcome. But if you don't want to drop the null value columns on rows, you can fill it up. There are various methods and strategies to fill these null values. First is to fill these null values with mean, median or mode. We use mean values to fill the columns mostly in numerical data. Mean value are used when our numerical data is evenly distributed. That is, it has normal distribution with not much outliers. But if there are big outliers in our data, then median method is preferred. Mode is used mostly for categorical or ordinal data. So we can fill the column with a mode value for ordinal or objective data. Another method of filling the null value is by forward fill. In this, if the next column has a null value, it is filled by the value of the previous column. Similarly, there is a backward fill method in which if a row has a null value, then it is filled by the value of the next row. And lastly, we can fill a null value with interpolation of the values of previous rows. It can be done mostly in time series data, where we can calculate a missing value based on the information from previous rows. So first method, dropping rows and columns with null values. For this, we will use the method called dropNA. So we use the method df.dropNA and it will drop all the rows and columns that contain the null values. So if we see df1.isNull.sum, then there are no null value column or rows. Now if we see the shape of our data after dropping the rows and columns, it has 5 rows and 11 columns. That means we have dropped 14 of our rows which were present, which had null values in all-time peak. But because our data is very small, this may not be an appropriate method. Another method is to drop the row and column in which all the values are null. For this, we use the method dropNA and pass the parameter how is equal to all. When we do this, it will drop only the rows and columns which have all the values null. When we say here, so none of our rows and columns are dropped because they had some values which were not null. For forward fill, we use the method .ffill. When we use the forward fill, all our null values are filled with the values of the previous row. If we see the shape of our dataset does not change. Similarly, we can use the backfill. So it is called bfill method. So when we use bfill and see, there are some null values still left because their next row may also contain null values. Now we create a dataset from our previous dataset df for manipulating and using mean median mode. So with df5 with ilog, we get whole dataset and make a new dataset df5. We took all the rows and all the columns with ilog and create a new dataset df5. Now we use the method mode. So to fill the null values with mode, we use the method .mode. and with square parenthesis 0, because dot mode give us the series of number. From those series of number we take the zeroth or the first value. So dot mode and 0 in square bracket, and we apply it on the all time peak column. df5 all time peak dot mode and in parenthesis 0. This give us the mode value. So it take the column all time peak of df5 and find the mode of it, and from the mode it took the first value. This is our mode value. Now we fill this mode value into our data set, all the NA values, all the null values. So for that we use a method called fill NA. So with dot fill NA we pass the parameter mode value and it fill all the null values with this mode value. And we do it only for our one column all time peak, because here we took the mode value of only all time peak. So we took a column all time peak df5 all time peak, and then we fill the values, all the null values of that column with mode value, and then pass this to our original data set. Now our all time peak has 0 null values. It is all filled by the mode values. Now handling the inconsistent data. So in inconsistent data there may be many abnormalities. There may be blank space, or the string may be in uppercase or lowercase, or there may be some characters which sneak into our data set, or there may be some characters which sneak into our data set due to wrong entry or converting a form of file into another file. Like if we convert the dataset from PDF to CSV, many characters may sneak into our dataset. So we need to clean those characters. So first method to remove the blank space from our dataset is called .str.strip. .strip is also a method present in the Python. So to differentiate it from the Python method, we use .str. It means that it is a pandas method. .str.strip. So we took our column artist and we apply the method So we took our column artist and we apply the method .str.strip. So it strip all the blank space in front and end of the column. Similarly, we can convert all this data into lowercase. We use the method .str.lower. And if we want to convert everything into uppercase, then we can use the method .str.upper. So here we have converted all the data into lowercase. Sometimes the column's name may also have some blank space. So to remove the blank space from the column names, we can use the method df.columns.str.strip. So df.columns get hold of all the columns in our dataset and then apply the method .str.strip, and we pass it into our df.columns into our dataset. So this removes all the space in front and end of our column names. Now after we strip all the blank spaces in our columns, let us see if there are any abnormal characters which is not desired in our columns. For this, we use the method REPR or representation. This method gives us the values which are printable. With this, we can know if any abnormal characters have sneaked in into our column names. If we see with df.columns, we cannot find any abnormal characters. Like here, in actual gross, there is a blank space. There is nothing abnormal here. But if we use this REPR column and use a for loop on our columns, so we can see in actual gross, in between there are some abnormal characters. There is not a blank space. To remove these abnormal structures or abnormal characters, we use the method .replace. So for our columns, we use df.columns and use the method .str.replace. And first parameter, we give the abnormal characters. And the second parameter, we give what we want in place of these abnormal characters. So we want a space here. So we give a space. So when we run this, we find a blank space. These characters are gone. In our data set, the actual gross column has $sign in front of the numerical values. If we want to remove this $sign in front of the numerical values, we can use the .replace method. We take the column actual gross and apply the method .str.replace, and first parameter we give the $sign, and in place of weight we don't want anything, just remove it, and we put regex is equal to false. Now if we see this column, the $sign is gone. So in our peak column, in our data set, we have these square brackets which are abnormal. We want to remove those square brackets from the peak column. For this, we use the library regular expression and we import it as import RE. This is regular expression library. So for this, we use the library regular expression. It is imported as RE and use the method to remove those brackets. So we took the peak column and applied the method re.sub. Here sub is substitution, like we do in dot replacement. So we substitute the brackets and objects inside it that starts with 0 to 9 and we replace it with blank. We don't want anything in place of it. Our data set does not have this square bracket. So those square brackets are removed. Now handling the data type mismatch. As you can see here that our peak column is an object. However, it should be an integer or a float. So to handle this, we first convert our peak column into a float. Then take a mean of the float values and fill all the null values. After that, we convert this column into integer column. So there are two methods. First is dot as type. If we use dot as type, we can put any data type inside the parenthesis like int, float, string, and convert the column into that data type. And another method is toNumeric. By using toNumeric or toDateTime, we can convert the column into that format. Like with toNumeric, we convert it into float, and with datetime, we convert it into datetime. So here we are taking the df peak or our peak column and converting it to the float data type, and we convert the peak column into numeric column. So after converting the peak column to floating data type, we fill the null values with peak.mean. Here we take the column and take the mean of it and fill with the method fillNA. Now when we see the head, we see that these are float values. And if we want to find the null values, we find that peak has no null value now. Now we want to convert the peak column from float to integer. So we use the method as type. Now our peak column is converted into integer. Now fifth part, dropping unnecessary data. So let us drop the last column, the reference column, which is not necessary for our machine learning process. So we'll drop the unnecessary data with the method called dot drop. Here we use dot drop method and pass the name of the columns we want to drop. Here we pass the name of the column and access is equal to 1. Access is equal to 1 means that we want to drop the column. If access is 0, that means we want to drop the rows. So df.drop square bracket reference. If we want to drop the multiple columns, we can put comma and put a name of another column into the square bracket and put access is equal to 1. So when we do this, so it say ref not found. So the error is because we put the wrong name, ref dot. Now we have dropped the column. If we want to drop a row, so let's say we want to drop the row number 20 and the axis is equal to 0. So we give the row number and axis is equal to 0. That means we want to drop a row. We can do that. Sorry, there are only 19 rows. So we will drop the 19th one. So our 19th row is dropped. Now handling duplicate values. So we have added two rows of the duplicate values into our dataset. When we see df.tail, we find these two rows are same. So let's see how to find with a method called dot duplicated the number of duplicated rows. So df.duplicated.sum, like we use is null.sum, here we use duplicated.sum. So when we use this, we get that one row is duplicate. To drop this duplicate value or duplicate row, we use the method drop duplicates. So df.drop duplicates. If we use this method, you see the duplicate row is dropped. Most commonly, we try to remove or drop the duplicate rows, which has almost the same duplicate numbers which the other row has. But in some case, we may want to keep these duplicate rows. Like in experimentation. If two experimentation get the same result, we may want to keep these duplicate rows. And if you like the video, please like and subscribe. Thank you.